Discrete mathematics is the study of mathematical structure that are countable or otherwise distinct and separable example of structure that are discrete or combination, graph, and logical statement. Discrete structure can be finite or infinite. Discrete mathematics is in contrast to continuous mathematics, which deal with structure which can range in value over the real number or have some non-separable quality. Since the time of Isaac Newton and until quite recently, almost the entire emphasis of applied mathematics has been on continuous varying process modeled by mathematical continuum and using method derived from the difference and integrated calculus. In contrast, discrete mathematics concern itself mainly with finite collection of discrete objects. With the growth of digital device, especially computer, discrete mathematics has become more than and more important. Discrete structure can be counted, arranged, placed into sets, and put into ratios with one another. Although discrete mathematics is wide of varied field, there are certain rules that carry over into many topics. That concept of independent event and the rules of product, sum, and pi are shared among combinatorics, set theory, and probability. In addition, the Morgan laws are applicable in many fields of discrete mathematics. Often what makes discrete mathematics problem interest and challenging are the restrictions that are placed on them all through the field of discrete mathematics. As many elegant formulas to apply, it is rare that applicable problem will fit perfectly to a specific formula. Part of the joy discovering discrete mathematics is to learn many different approach to problem and solving, and then to able to creatively apply disparate strategies toward the solution.
Hi guys, I am here to discuss about compound proposition. What is compound proposition? Compound proposition is a new proposition constructed by combining one or more existing propositions. First one is negation. Referred to as not operation, meaning this contradicts the initial statement. The symbol being used is, for example, the given value is P. If we are going to get its opposite value, it would be not P. This can be written as P with a bar above it, or apostrophe P, not P. And there is also the punctuation mark P. The most commonly used is the one with the bar above it. Let's proceed to the truth table. In the truth table, we initially put the given value. Let's say P, we have false or equal to 0. And true or equals to 1. P is not P is not constant. It can be A, B, or C. Any letters will do. This is because the only value we can use here is 0 and 1. And if we have the value of 0 and 1 for P, we will just provide its contradiction, which is not P. This means if we have 0 for P, its value for not P is 1 or true. Because for not P, you just need to provide what is opposite of the value of P. And the other value of 1 for P is just the process. You just provide the contradiction of 1, and that is 0 or false. Which is are not P. I hope you learned from this. Thank you for watching.
Isang magandang araw sa inyong lahat. So, magdi-discuss ako ngayon. Hulaan nyo. Ano yung di-discuss ko? So, ang i-discuss natin for today is about set. Ayan, set. Nakita niyo dyan. Set. So, ano nga ba itong set na to? Napaisip din ako bigla. So, itong set na to, ito yung group of elements. If combined, makakabuo ko ng set, kumbaga. So, hindi na ako magbibigay ng example. Mamaya magbibigay tayo. Afterwards na ma-discuss lahat itong ano nga ba itong set ito? Lahat, pag na-discuss to, magbibigay tayo example. So, first one is universal set. From the word itself, universal means all. Lahat ng relevant in this discussion, kailangan nasa loob ng universal set yan. Mamaya na, di-discuss natin yan furthermore kapag nagkaroon tayo examples. So, notation, same, di-discuss natin yan kapag nagkaroon ng examples mamaya. Infinite set. Ano nga ba ito infinite set? Okay. Infinite means not countable, endless, limitless. Infinite set means the number of elements is or are not countable. Yun na nga. Self-explanatory na siya. Kumbaga, alam naman natin, infinite. Hindi siya nabibilang. So, yun. Next one is finite set. Yun. Counterpart siya ni infinite set. So, it means finite set is a set of number or a series of numbers or elements which is countable. Alam niyo yun? So, nabibilang siya. Meron siyang endpoint. Meron siyang limit. Ayun. So, let's move on to the next one. Set equality. Okay. From the word itself, equality. So, ayun. Means, two sets should be equals or identical. Exactly the same. Alam niyo yun? So, it means those elements that is present on set A should be present on set B. In that way, doon lang siya mako-considered as set equality. Ayun. So, na-discuss na natin lahat. Magbibigay tayo ng example ngayon. And, magdi-discuss na rin tayo ng konti. Kumbaga, additional information sa mga ito. Kung ano nga ba itong set na to. So, yun. Lipat lang tayo sa paint. Ayan. Dito na tayo sa paint. So, ayan. So, yung first na example na ibibigay ko is about dun sa set nga kanina. Sinabi kong set kanina. Etong set na to, ay lang, hindi ko pa nabibigay yung description ng elements. So, yung elements, ito yung nakapaloob sa set. Kumaga, sila yung ginugrupo para makabuo ng set. So, yun na nga. Etong mga to, yan, wait lang. Kuha tayo ng to. Itong mga A, B, C, D na yan. Ito, elements yan. Elements. Yan, sana maintindihan yung sulat ko kasi pangit talaga yung sulat ko. Ayan. So, ay, nabura siya. Sorry. So, gamit ko kasi pentab today. So, yan. Etong buo na to, kapag pinagsama-sama mo lahat ng elements, is makakabuo ka ng tinatawag natin ngayon na set. Ayan. So, nakapagbigay na tayo ng examples ng set. Let's move on to the next one. Yung universal set. Ito. Nakikita nyo dyan. Tulad din na sabi ko kanina, ang universal set should be containing all the elements relevant to a particular discussion or problem. So, we have here an example. Kinuha ko yung consonant and vowels. And ito alphabets. So, consonant. This is set consonant. The other one is set vowels. Okay. So, kapag pinag-merge mo sila or pinag-combine, makakabuo ka ng yan, alphabet, which is yung universal set natin. Ayun. So, madali lang naman siya. Kung ano lang naman yung related sa, ayun, or relevant sa discussion, or kung ano yung set na nakikita mo sa discussion, dapat lahat ng elements nun, makikita mo dapat sa universal set. Ayan. Nakikita niyo naman. Yung A, E, I, O, U, makikita mo dyan. Yung yan, yung consonant, makikita mo rin dyan. So, yun. Yun yung universal set. Next one is finite set. Okay, finite set. Dito na ba ako? Ay, hindi. Sa notation muna tayo. Notation. Ito. Okay. Kunwari, may example tayo. Ayan. R equals to 1, 2, 3, 4, 5. Ayan. Dito naman sa notation, tinitingnan na ito kung present, if present yung element sa set, kumbaga. So, yan. Example natin is R equals to, let's just say, 6. Yan, 6. Nakikita nyo ba yung 6 dito sa set na to? Di ba hindi? So, it means hindi siya present sa set na to. Means, ito siya. It means, this is not an element of set R. Gets nyo ko? Okay, so, isa pang example is yan. R equals to 1. Nakikita nyo ba yung 1 dito? So, yun. Kapag nakita nyo, ayan, nakikita. Ito si 1. So, yan. Dahil nakita mo si 1 dyan, it means present siya sa set na yun. It means element siya ng set na yun. Ayun. Ito siya. Another example is R equals to 7 naman. Okay. Since 7 is not present on the set R, it means it is not an element of set R, of course. Yan. So, okay, last example is ito. R equals to 2. Yan. Since 2 is present to the set R, means 2 is element of set R. Okay? Mali. Ay, sige, okay na. 2 is element of set R. Yun. So, basta kung if the elements is present on that particular set, it means it is an element of that set occurs. Okay. Next one is finite. Okay, finite. Let's start with finite set kasi since magkasama naman sila ni infinite set. So, finite set. Where sinabi ko nga kanina, finite set is countable, limited. It has an endpoint. Okay? So, makikita natin dito, 1, 2, 3, 4, 5. Ito na yung endpoint niya, yung 5. Diyan siya nagli-limit, kumbaga. Alam niyo yun? Kaya siya na-define as finite set kasi nga, meron siyang endpoint. Ito yung endpoint niya. Hindi na siya tumutuloy. And nabibilang din siya. So, yan. Infinite set. Example nito is integers. Yan. Integers. Ano nga ba itong integers natin? Meron siya negative. It composed of negative and positive. Positive numbers. So, let's just say, example is 1, 2, 3, 4, blah, 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 hanggang mag 1 million. Then, tuloy-tuloy pa rin. Hanggang hindi siya natatapos. Kumbaga, continuous siya. Endless nga siya, di ba? So, ganun yung infinite set. Kumbaga, yun. Hindi nga siya countable. Okay? So, next one is set equality. Okay? So, ito, set equality. Sabi dito, yung set equality daw is composing of two sets. Of course, ayan, nakikita nyo naman, dalawang set na present ko. Then, itong two sets daw na to, kailangan, nagko-contain sila ng exactly the same elements. So, kailangan parehas sila. Ayan. So, tignan natin kung magkaparehas nga ba itong set A and set B natin. So, sa set A, ito, 1. Meron bang 1 sa set B? Of course, meron. Ayan. Ito si 1. Yan. Ano ba itong number na to? 8 ata to. Tanggalin na natin. Ayan, 8. Meron ka ba nakikitang 8 sa set B? Of course, meron. Ayan. Ito nga si 8. Ayan. So, number 9. Next. Number 9. May nakikita ba number 9 sa set B? Of course, meron. Ayan. Kitang-kita naman. So, yan. 6. Of course, ito. Nasa pang-una. 3. Ito, nasa gitna. Ayun. So, matatawag ba nating equal sila? Of course, yes. Kahit hindi siya in order, at least, magkaparehas pa rin sila ng content. Kumbaga, kung ano yung laman ni set A, yun din yung laman ni set B. Ayun. Yun yung set equality. Tulad nga sabi dito, exactly the same. So, yun lang naman yung set. Yun lang naman yung topic natin about set. Yun lang naman yung content ng set natin. If you like this video, click the like button and subscribe button. Also, the notification bell for more updates. Also leave a comment down below. Then we'll decide if we're going to create another video for a set of topics that we'll discuss. Okay, so thank you everyone for watching. This is Dan.